A company makes and sells fibre optic cable. It can sell, at most, 200 kilometers of cable in a week. For a certain range of its production, the company has found that profit can be modelled using the function P of x is equal to 275x minus x squared minus 2000, where x is less than or equal to 200. In the function, x is the number of kilometers of fibre optic cable sold, and P of x is the profit in euro. In part A, we're asked to use the profit function, P of x, to find how much money the company loses if it does not sell any cable. In the profit function, x represents the number of kilometers of cable sold. The key observation here is that not selling any cable is equivalent to selling 0 kilometers of cable. So here, x is equal to 0. To find our profit, all we have to do is to sub x equal to 0 into our profit function. We have got an answer of minus 2000. In the context of profit, a minus sign means that we're losing money. So our final answer here is that the company loses €2,000 if it does not sell any cable. In a particular week, the company made a profit of €8,350. Find the number of kilometers of cable it sold that week. As a reminder, the profit function was defined at the top of the question to be P of x is equal to 275x minus x squared minus 2000. Here, we're given a target profit, 8,350. So we need to set our profit function, P of x, equal to 8,350. This equation has an x squared term, an x term, and some number terms. We call this a quadratic equation. The quadratic formula can be used to solve this. However, before we can use it, we'll have to rearrange the equation into the form ax squared plus bx plus c is equal to 0. In other words, we should group all the terms on one side and leave a 0 on the other side. The easiest way to do this is to remove the plus 8,350 from the right-hand side. The inverse of addition is subtraction, so to remove this we should subtract 8,350 from both sides. Now, we can do some simplification by combining the number terms. Minus 2000 minus 8,350 is minus 10,350. From here, I'll reorder our calculation so that the x squared term comes first, the x term comes second, and the number term comes third. Writing things in this format will make the application of the quadratic formula a lot easier. I've also rewritten the minus x squared as a minus 1x squared. Again, the reason for this is that it will make it easier to apply the quadratic formula. Let's remind ourselves of the quadratic formula. It states that the roots of the equation ax squared plus bx plus c is equal to 0 are x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. In this formula, a refers to the number in front of the x squared. Here, a is equal to minus 1. B is equal to the number in front of the x, and here b is 275. C is the number all by itself, and here c is minus 10,350. Now that we know the a, b and c, we can sub in to the quadratic formula. Here, we can get out our calculator and do some simplification. The calculation beneath the square root comes out as 34,225. And underneath the line, we have 2 times minus 1 being equal to minus 2. Now, we can use our calculator to simplify further. The square root of 34,225 is equal to 185. The next step is to deal with this plus minus symbol. This means that we need to split into two cases. In the first case, we replace the symbol with a plus, and in the second case, we replace the symbol with a minus. From here, we can use our calculator to calculate both of these expressions. So we've ended up with two answers, 45 and 230. At first glance, both of these seem plausible. However, if we carefully reread the top of the question, it mentions that the company cannot sell more than 200 kilometers of cable. So that rules out the 230. So our final answer here is that the company sold 45 kilometers of cable. The table below shows some of the data representing the profit on sales. Use the profit function, p of x, to complete the table. Well, we're told at the top of the question that the profit function, p of x, is equal to 275x minus x squared minus 2000. To fill in the table, we must sub in the provided x values into this function. The first x value we are given is 50. So we should sub in x equals 50 into our function. In other words, everywhere we see an x, we should replace it with a 50. Our answer here is 9,250. So the profit when we sell 50 kilometers of cable is 9,250. The next x value we are given is 60. So here we sub in x equals 60 into our profit function. The answer we get is 10,900, and this represents the profit when 60 kilometers of cable is sold. The next entry in the table is already done for us. We've been told that if 70 kilometers of cable is sold, there'll be a profit of €12,350. To finish off this question, all we need to do is sub in x equals 80, x equals 90, and x equals 100 into our profit function. Use the data in the table to draw the graph of the profit function on the axis below. For 50 is less than or equal to x is less than or equal to 100, where x is an element of the real numbers. On these axes, the horizontal x-axis is labelled with the number of kilometers of cable sold. The vertical y-axis is labelled with the profit. The data in the table from the previous part of the question tells us the points that we should plot. The first column of our data tells us that if we sell 50 kilometers of cable, we'll make a profit of 9,250. So here, the point we need to plot is 50, 9,250. The next point is 60, 10,900. The next point is 70, 12,350. The remaining points can be plotted in a similar way. We have now plotted each point from our table. To complete our graph, we should join these points with a smooth curve. Use your graph to estimate the lower and upper range of sales in kilometres of cable in order to make a profit of between €10,000 and €14,000 in a particular week. Show your work on the graph. The lower bound of the profit that we're given is €10,000. We can use our graph to estimate the number of kilometres of cable sold, which corresponds to this profit. To do this, we begin by drawing a horizontal line out from 10,000. When we meet our blue curve, we drop a vertical line straight down. This line hits the x-axis at a value of around 55. The interpretation of this is that we obtain a profit of €10,000 when the number of kilometres of cable sold is approximately 55. The upper bound on the profit that we're given is €14,000. Again, we can use our graph to estimate the number of kilometres of cable sold, which corresponds to this profit. To do this, we begin by drawing a horizontal line out from 14,000. When this line meets our blue curve, we drop a vertical line straight down. This line meets our horizontal x-axis at a value which is approximately 83. We were asked to estimate the lower and upper range of sales to make a profit between €10,000 and €14,000. We found that 55 kilometres of sales corresponds to a profit of 10,000 and 83 kilometres of sales corresponds to 14,000. So the lower bound here is 55 kilometres and the upper bound is 83 kilometres. Use calculus to find the number of kilometres of cable sold when the profit is increasing at a rate of €105 per kilometre. This question involves a rate of change. Specifically, we need to know when the profit is increasing at a rate of €105 per kilometre. A useful fact to know here is that derivatives represent rates of change. Here, we are interested in the rate of change of the profit P of x. The derivative P dashed of x will represent the rate of change in this profit. So the first step is to differentiate our profit function P of x is equal to 275x minus x squared minus 2000. When it comes to differentiation, if we're adding or subtracting terms, then each term should be differentiated individually. Let's start with the 275x. There's a useful differentiation fact which says that a number times x differentiates to the number. So 275x will differentiate to 275. To differentiate the x squared, we should use the rule for differentiating powers of x. This states that we should multiply down by the power, then reduce the power by 1. Here, we should multiply down by 2, and then reduce the power from 2 to 1. So after we differentiate, we get 2x to the power of 1. By convention, we don't bother writing in the power of 1, so we can write this as 2x. The final thing to differentiate is the 2000. There's a useful differentiation fact, which says that a number by itself differentiates to 0. So the number 2000 will just differentiate to 0. In other words, it will disappear. So we found our derivative. P' of x is equal to 275 minus 2x. Remember, our goal here is to find where the profit is increasing at a rate of €105 per kilometre. In other words, we want the rate of change in profit to be equal to plus 105. The derivative we just found represents the rate of change in profit. So the next step is to set our derivative equal to plus 105. From here, it's a matter of solving for x. In other words, isolating x all by itself on one side of the equation. The key thing to keep in mind is the following. To remove something from one side of the equation, we must perform the inverse operation to both sides. Here, let's start by removing the 275. This represents addition. The inverse of addition is subtraction, so to remove a plus 275, we should subtract 275 from both sides. Now, let's focus on the minus 2 in front of the x. This represents multiplication. The inverse of multiplication is division, so to remove multiplication by minus 2, we should divide both sides by minus 2. So we found that x is equal to 85. In this question, x represents the number of kilometres of cable sold. So our final answer here is that the profit is increasing at a rate of €105 per kilometre when 85 kilometres of cable is sold.